Welcome back. Talking to the camera feels a little bit odd, almost as if I'm starting all over again. And for many people, this is exactly what the new year is all about, a fresh start. You're probably wondering where I've been during this spontaneous break. Unfortunately, there is no simple answer to this because I was busy with variety of things like job, university, ICPC season. And I think it was a little bit overwhelming for me. So last time I set the pace pretty fast, sometimes releasing multiple videos a week. And while taking part in multiple contests is not that difficult, recording screencasts and editorial is actually pretty hard. So I want to take things slower this time. Let's first make it a weekly routine for us to have a practice session and the corresponding video. And then separate of that, we may have occasional screencasts or editorials whenever I feel like I did something good and I'm ready to share it with you. I've also set up a Google Calendar for me to keep track of contests that I want to take part in. The link will be down in the description box, and you can subscribe to it if you want to have, I don't know, a rough idea of when to expect a new video, right? So that even if I get some unexpected business, right, I'll let you know through the calendar or potentially on the community page. So yeah, I don't promise to participate in every contest on that list because it's relatively large, but I'll try my best to keep it updated and sync with my other activities so that, once again, we don't get an unpredictable break. With that in mind, let's jump into a super fast practice session. So I started with a problem from Codeforces. This problem you're given a super long sequence, which is a repetition of some smaller array. And once you notice the product constraint, which I had highlighted, it's pretty obvious that the solution will involve some sort of dynamic programming. As we can see, like I'm counting sequences of given lengths and like given at certain values. Fortunately, I spent a real long time implementing this problem. And I had a bug, pretty obvious, that I couldn't find for a long time because I simply should have been paying more attention. Like, I should have written down the definition of my DP because by this point I have. No, okay, not by this point, but soon enough I'll have an almost working solution, and then I'll spend like half an hour more to make it accepted. Yeah, so around here it's pretty much probably not yet. Yeah, by this point it's pretty much correct. It's like one small thing off. So I first noticed the mistake that I didn't mod a large product. Unfortunately for me, I have one more mistake in the same line, but for some reason I really believe that the first part, when we count like simple sequences, is correct. And I saw that I have some bug in the second part when we count sequences that end in an incomplete block, so to say. So I tried to rewrite it like multiple times, change random bits of the code, whereas I really should have just written down what my DP is, because then it would have been fairly obvious that I want to change the same line. So at this point I'm still thinking that the mistake is in the second part. And then I say it's not. I still think that it's in the second part. Then I realized that maybe it's not there, and like it's literally the first thing I fixes the problem. So yeah, we get accepted here. Next up is an ad hoc problem from AtCoder. It's a game between two players, and it's pretty clear that it is an ad hoc. You basically have to figure out what are the reasonable strategies for the players. Unfortunately for me, I couldn't come up with the correct strategy. First, I thought that maybe just simple if-else logic, like let's count all turns of special form. Unfortunately, yeah, then I realized, okay, maybe it's not that simple. Maybe we should employ some sort of greedy, and I use priority queue for that. Unfortunately, it doesn't work. I try to change some random things, it still doesn't work. And yeah, I really just struggle with this ad hoc problem. So it clearly hints towards that I should practice more ad hoc, right? And I actually, after 4 wrong answers, I decided to come up with my own test case. And then I realized that our problem can be rephrased as a knapsack. Unfortunately, this knapsack has a size of 10 to the 5th and weights up to 10 to the 9th. I have a brief moment where I think that it may be solvable with bit sets, but it's not. So I'm basically stuck at this point. I tried to think for like half an hour more, but then I give up. Look up the editorial. I tried to read just several lines, as you can see, and then try to translate that logic into code all by myself. I'll actually succeed, but it's still not obvious. As you can see, I spent a substantial amount of time trying to understand what the solution is, what the idea is, but then I get accepted with something like that. Last problem for Saturday was a constructive problem from CodeChef. In this problem, you need to construct some tree to satisfy certain conditions and color the vertices of this tree in 3 colors, red, green, blue. So every path between 2 blues has to contain both red and green. First, I start with some really creepy casework. As you can see, like I think, okay, what if there are too many reds? What if there are too many greens? What if there is some sort of balance? Luckily for me, I decided this is way too creepy. And then I come up with this beautiful approach that I think it's pretty much a bipartite graph. You can visually see why it works. So yeah, this is so much better. So by this point, I'm just implementing boring stuff. I actually make one mistake here. For some reason, my code doesn't work on samples, but it doesn't bother me. So I submit, and then I read carefully. No, actually, I tried to implement like stress testing for this problem, then I realized that let's actually come up with a test case when it doesn't work. Then I do, and I realize my mistake, and I solve the problem. The following footage is from the next day. I was not in my usual place, so I couldn't record the webcam. So first, I started out with a very pleasant geometry, so to say, problem from Codeforces. In this problem, you're given a set of 2D points, and you want to construct a reasonably short Hamiltonian path. After investigating the meaning of reasonably short, I quickly got some square root ideas, and I just implement something. I also wrote like a sanity check in case I want to make a stress test, but luckily it was not necessary, so I quickly fixed it. So first I had a bug in like number of groups should be +1, and second there is heuristic approach that improves. Then I proceeded with an AtCoder problem. It took me longer to solve and implement. In this problem you are given a set of people, each starts walking to the right on the number line in some time moment, and you are also given a number of roadworks that stop people at certain point in a certain time interval. So I call such problems event processing because each time interval constitutes two events, the beginning and the end of the segment. Initially, I wanted to overkill this problem with a segment tree to basically min-assign, because every roadblock stops a range of starting times, and then you just want to take the minimum roadblock that stops you. Luckily, I then realized how to do it without a segment tree. It took some time debugging, but reasonably soon the problem was solved. So yeah, sometimes it makes sense to stop your segment tree idea and come up with something simpler, because segment tree would have taken me a bit longer to implement. It also needed to be lazy, I believe, to min-assign and range. So yeah, event processing is definitely a useful technique. You should learn it. But for us, that's it. All the links to the problems in my submissions will be down in the description box. Alternatively, you can also check the logs in the calendar. I try to log every practice session. But for now, that's it for me. So thank you everyone for watching, and I hope to see you around soon.